Hi viewers, welcome to JSC. In the last class, we discussed some of the classifications of elements. In this class, I am going to discuss Mendeleevs classification. So Mendeleevs classified totally 63 elements, so which are known at that time, and he classified elements from hydrogen to uranium. Okay, hydrogen to uranium, total 63 elements he classified. Okay, he classified and he arranged elements based on the increasing order of atomic weight or atomic mass, and also he took physical and chemical properties of elements. Okay, he took physical properties means here melting point, boiling point, density, etc. So chemical properties means here so reaction with oxygen and reaction with hydrate. So when these elements react with oxygen forms oxides, and when these elements react with hydrogen they form hydrates. Okay, so based on that physical and chemical properties and atomic mass, he given a periodic law. So that is the physical and chemical properties of elements are periodic function of their atomic masses. Okay, that means physical and chemical properties of the elements, those are depends upon their atomic masses, and he arranged these elements in 8 vertical columns. Okay, 8 vertical columns and 7 horizontal rows. So totally here 8 vertical columns are there. So these are called as groups. So 8 vertical columns, these are called as groups, and 7 horizontal rows, these are called as periods. These are called as periods. 8 vertical columns, those are called as groups, and 7 horizontal rows called as periods. So these 8 vertical columns, again in that 7 vertical columns are classified into 2 types. Okay, here this group contain 2 subgroups A and B. Okay, each group contain subgroups A and B, and there is no subgroup in the 8th group. Okay, from first group to the 7th group there are subgroups. Okay, they are classified into A and B. So there is no subgroup in the 8th. Let us see. So this is the original Mendeleev's periodic table. So later it is modified and noble gases added to this Mendeleev's periodic table by the Ramsay and Relic. So like this. Here helium, neon, argon, okay, krypton, and xenon and radon. Okay, helium, neon, argon, krypton, xenon and radon. So these are the noble gases which were introduced into Mendeleev's periodic table by the Ramsay and Relic. Okay, so then let us see what are the merits of this Mendeleev's periodic table. So when come to the merits of Mendeleev periodic table, so he arranged total 63 elements known at that time. Okay, total 63 elements he arranged in his periodic table. Total 63 elements, and he arranged these elements based on atomic mass as well as based on the physical and chemical properties. That is one of the major advantage of Mendeleev's periodic table. Okay, he arranged these 63 elements from hydrogen to uranium. So based on their properties also, along with atomic mass, he took properties, physical and chemical properties to classify the elements. And so it is a third merit. He left some gaps for the elements yet to be discovered. Okay, he left some gaps here, 1 2 3 4 Okay, these gaps for unknown elements, so those going to discover later. Okay, he left some gaps for elements yet to be discovered. So this is the major achievement of Mendeleevs. Okay, this is a major achievement of Mendeleev and advantage of Mendeleev periodic table. So, okay, he left this gap not only based on the simple properties, he left this gap based on the physical and chemical properties of these unknown elements. Okay, he left this gap based on the physical and chemical properties only. It's not simply. Okay, so let us see what are the elements so which were discovered later. So here, Eka boron, next Eka aluminium, and Eka silicon and Eka manganese. So these are the four names given by the Mendeleevs for unknown elements. Okay, for these unknown elements only he given gaps. So let us see what is Eka boron. So Eka boron is a scandium, so which were found later. Eka aluminium is a gallium, Eka silicon is a germanium, and Eka manganese is a technetium. So let us see where we have to place these elements. Okay, Eka aluminium, Eka boron, here scandium will come. Okay, Eka aluminium, here gallium. Okay, next Eka silicon, here germanium. Next Eka manganese, that is technetium. Okay, so these are this is the major achievement of Mendeleevs. And okay, he left this gap based on the physical and chemical properties. So what are the physical properties? He took density and melting point, and when come to the chemical properties, reaction with oxygen and reaction with chlorine. Based on these physical and chemical properties, okay, he left these gaps. Okay, so these are the merits of Mendeleev's periodic table. Let us see demerits or drawbacks of Mendeleev's periodic table. So let us, the first drawback is position of hydrogen. Position of hydrogen is uncertain because this hydrogen shows similar properties with this first group elements, isolize with seventh group elements. Okay, hydrogen shows similar properties like lithium, sodium, potassium, rubidium, cesium, isolize with fluorine, chlorine, bromine, iodine. But it is placed in first group. So what is the reason? Does not explained by the Mendeleev. That's why this is the first drawback of Mendeleev. Position of hydrogen is uncertain. Second one is position of isotopes. Position of isotopes. So for example, if you take hydrogen exists in three isotopes: hydrogen and deuterium and tritium. So they have same atomic number but different mass. When they have different mass, they should be placed in his periodic table. Okay, so when isotopes have different mass, they should be placed in his periodic table, but these isotopes are not placed in Mendeleev's periodic table. So that's why this is one of the drawback. Next, let us see some of the lighter elements, means less atomic weight elements, placed after the higher atomic mass containing elements. Okay, or also we can say some of the heavy atomic mass containing elements placed before the less atomic mass containing elements. So those type of pairs are called as anomalous pair. Anomalous pair, or also we can call inverted pair. Inverted pair. So means here some of the heavy atomic mass containing elements placed before the less atomic mass containing elements according to the Mendeleevs. So what is the correct? Okay, that he arranged elements based on the increasing order of atomic mass. When you observe that, when cobalt present here, nickel present here. Okay, that means iron, nickel, cobalt is the correct order. But he arranged iron, cobalt, nickel. So for this, there is no reason by the Mendeleev. Okay, so let us see what are the anomalous pairs are present in Mendeleev's periodic table. So one is cobalt and nickel. So cobalt atomic mass is 58.98, nickel atomic mass is 58.71. Okay, heavy atomic mass element placed before the less atomic mass element. So like that, second one is tellurium and iodine. So tellurium atomic mass is 127.60, iodine atomic mass is 126.90. Heavy atomic mass containing element placed before the less atomic mass containing element. Let us see next one, third one. Argon and potassium. Argon and potassium. Argon is 39.9, potassium is 39. Okay, argon 39.9, potassium 39. Heavy atomic mass containing element placed before the less atomic mass containing elements. So that's why this is the one more drawback of the Mendeleev's periodic table. The elements with different properties placed in same group. The elements with different properties placed in same group. Same group. Example. Here first A group elements is the first group in A. First A group elements and first B elements like copper, Ag, Au, and here lithium, sodium, potassium, rubidium, cesium. So they shows different properties. Okay, they shows different properties. Okay, example, first A elements and first B elements. Okay, they shows different properties but placed in same group. Okay, next, position of transition elements. Position of transition elements. So transition elements where are present here? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium. So these are the transition elements. So which are placed along with representative elements. Here representative elements with, when you see the modern periodic table, S block and P block elements are called as representative elements. So here transition elements placed along with representative elements. Okay, so that is also one of the drawback of Mendeleev periodic table. For this there is no reason by the Mendeleev. Next, sixth one, lanthanide and actinide position. Lanthanides and actinide positions. Actinides position. So when you see the lanthanides here, lanthanum, okay, and thorium, okay, lanthanides and actinides. So these are not satisfied by Mendeleev. These positions are not satisfied by the Mendeleevs. So these are the drawbacks of Mendeleev's periodic table. Already we discussed merits and demerits. So let us see once again. Here when come to the merits, okay, he arranged all the known 63 elements in his Mendeleev's periodic table, and he arranged elements based on atomic mass as well as with physical and chemical properties, and he left some gaps for unknown elements, so which were discovered later, and some special names given to unknown elements, and he predicted the properties of unknown elements also. So what are the special names given? Eka boron, which named scandium, Eka aluminium, which is named as gallium, Eka silicon, which is named as germanium, Eka manganese, which is named as technetium later after discovery. So let us see the demerits. The position of hydrogen is uncertain. Okay, means hydrogen shows similar properties with first A elements, means alkali metals, and seventh A elements with halogens. Okay, that's why the position of hydrogen is uncertain. Okay, according to the alkali metals, hydrogen exists as H plus. It shows H plus. According to the halogens, it shows H minus hydride. This is proton. H plus proton, H minus hydride. So that's why the position of hydrogen is uncertain. Then, as atomic masses is considered as a major part of the Mendeleev's periodic table. So based on that, so we have to give some places, we have to give positions for isotopes. Okay, so based on that, for example, if you take hydrogen 1H1, that means this is hydrogen, this is deuterium, this is tritium. Here mass number is 1, here mass number 2, here mass number 3. So when these isotopes have different atomic masses, they should place it at different positions in Mendeleev's periodic table. But like that not happened. So that is one of the drawback. Next, some of the elements with high atomic masses placed before the elements with lower atomic masses. For example, argon, potassium and cobalt, nickel, tellurium and iodine. So those pairs are called as anomalous pair or inverted pair. The elements with different properties are placed in same group. For example, first A group alkali metals and first B group elements copper, silver and gold. They are called as kyanage metals. Along with alkali metals, kyanage metals also placed in one group, even though they shows different properties. That is also drawback. And place transition elements with representative elements. Okay, next, position of lanthanides and actinides unsatisfied. Okay, so these are the merits and demerits of Mendeleev's periodic table. So on the honor of Mendeleev's, one of the element in the periodic table named as Mendeleevium. Okay, on the honor of Mendeleev, one of the element, 101 element named as Mendeleevium. Okay, let us see one more merit here. That is, he corrected atomic weights of some elements. Atomic weights of some elements. Those are beryllium, indium, osmium, arum, platinum and uranium. So by using a valency, means atomic weight equal to equivalent weight into valency. Equivalent weight into valency. So by using this, okay, he corrected atomic weights of these elements: beryllium, indium, osmium, arum, platinum and uranium.